Hello, welcome to an episode of Beam There, Done That. Again, with my glorious, now free co-host, Francesco Cesarini.
Hi there, I'm Francesco, also co-host, no longer technical director. And yeah, straight from ElixirConf in Malaga, today we have Chris McCord joining us. Chris, why don't you introduce yourself?
Hello, yeah, I'm Chris McCord. I'm the creator of Elixir's Phoenix framework. Released a few other libraries recently, but yeah, thanks for having me on. Amazing podcast name, by the way. Happy to be here.
Yeah, I like that. I
Well,
came up with that myself.
It's very good.
it wasn't me, even though yeah, you could have thought that. Any exciting news? What have you been working on lately?
Yeah, so at ElixirConf just released a few new libraries that kind of were born out of product development over the last year. So working on kind of like durable objects in Elixir, something called DurableServer, and from that shipped a new distributed process registry and process group that has some interesting features and a distributed key value store as well that we just extracted out of the production app that we have running 20 nodes spanning the cluster, or sorry, spanning the world currently. So there's some interesting multi-regional Erlang distribution to talk about. But yeah, that's what I've been up to. Few things.
Well, before we get on to what the new stuff you've been working on, I kind of wanted to get like a state of the union within like the Phoenix kind of umbrella. I saw that there's just a new RC candidate update for Phoenix LiveView, but I haven't heard much about Phoenix, if there's another version coming out soon or if things are kind of stable. Do you mind to kind of give an update about all those libraries first?
Yep. Yeah, Phoenix. So Phoenix has been pretty well baked for several years now. So, Phoenix LiveView is where the majority of our feature work has happened over, I'm going to say, the last 5 years. And that didn't need to happen inside Phoenix. So Phoenix itself has gotten very few new features. I can't think of anything relevant other than like, let's say some convention generator changes has really been the only thing that's changed, like where what the directory structure looks like, but that's all optional, and Elixir and Beam doesn't enforce any of that. So Phoenix has been baked for a long time. LiveView itself, it took us a long time to get to 1.0, almost I think 5 years. But now that it's 1.0, it's been also kind of evolving much more slowly, which is the goal. To it's worked out that we kind of stamped 1.0 and we haven't made major changes. So I think we necessarily took a long time, but took the right steps. And at this point, I've just been building, doing product development work for the last year solidly, just using the framework and using the framework features. So right now things are, basically I need what I have, and I like to tell people the biggest driver of new features is like, is there a problem that sucks that Phoenix doesn't address that can't be solved well with like existing libraries in the community? And if so, then that's my priority. Like, oh, well, I'm going to go make this not suck for myself. And then the second closest priority is like someone comes to me like in production, like, here's my grievances, here are the things that suck. And then I make that better. So, lower in the list is, individual complaints on like, wouldn't it be nice if, but if you can tell me, here's a real product that, we find something like severely lacking, that kind of drives, feature development. And unfortunately, historically, through contracting, I play at like Dockyard. I've gotten a lot of exposure to real products, and now working at Fly, I've gotten exposure to 3 products now, basically large products that I'm even able to also drive feature development. So my open source work isn't just like done in a vacuum, me dreaming up features. It's very product led needs, and I feel like for the last couple years we've gotten to a point where I'm just gleefully using the features of Phoenix and LiveView and Beam and getting to do everything I could dream of and more just with what's there. So pretty well baked is the answer.
Now that you're talking about all these different updates, one I thought was actually pretty interesting is that definitely came out, which was pretty cool, is you're starting to add some more like useful things in LiveView, such as some more warnings that you can also turn off and on. I think now you have to actually require the ID being there. I think you're actually going to like detect that, provide a warning. Another thing that's interesting too is that you had the co-located JavaScript before. Now you've changed it to now co-located assets. So it looks like now you can have CSS in JavaScript. Now, but using the word assets, what just came to my mind right now is that also going to include images in the future or SVGs or something like that. Where is this kind of going?
Yeah, that's interesting. I mean, SVGs are, it's just markup. So SVGs, like you can just do it, right? But images, that's interesting. I don't think so, but I actually hadn't considered. So you're kind of saying like, if we could pre-break at compile time, the assets directly in the DOM, such that they're only served in those specific cases. Like there could be something interesting there. I guess the issue is like caching wise that may or may not make sense, but I have to think more about this because we weren't thinking really beyond co-located JavaScript and CSS, but there may be something there that makes sense for other types of assets. The other interesting thing around this work though is it kind of and this is what Stefan Deutsch on the Phoenix team talked about at the conference. One of the things he talked about is like part of the tag engine changes that allowed co-located hooks and co-located CSS to happen also gives us an interface that we haven't yet made public that we'd like to once we kind of settle on what the AST looks like. But internally, we had to make this interface that allows you effectively to make macro components, which basically means you can receive a representation, an AST of the Heeks template, and then modify that at compile time. So we are doing that with internal APIs, and it's something that we could make public at any time once we're happy to stamp the AST structure. But that would let folks do things like, there could be a macro component that you could have like, markdown in your Heeks, and that thing at compile time then produces an artifact that is like a rendered markdown. So there's some interesting things that kind of fell out of this effort, but asset wise I have to think more about, because I can't think of anything at the moment that doesn't have trade-offs that outside of CSS and JavaScript.
Is there going to be more swappability from within Phoenix itself? Because I mean, Phoenix LiveView is kind of a swap-in thing, where it's an add-on more so, where you can swap out the dead views, as you like to call them. What about swapping out something like, say, WebSockets with server sent events? Because when I look online between people think that what they like, I see a lot of people liking server sent events more than WebSockets because they find maybe in JavaScript the bidirectional facility is just maybe too complicated for them to work with.
Yeah, so I've had request has come up a lot for years. So for me, server sent events, this is like my hot take, like they're irrelevant as far as the client side code that you write as the developer on the client and server. The transport is abstracted. So if HTTP3 quick takes over, that becomes a thing. Like the goal is like our abstractions actually don't change on client and server for the developer. And I feel like that was the right call. And server sent events to me are irrelevant when you have WebSockets. So like, why would I forego bidirectional communication if I could just have bidirectional communication that happens to only send events pushed from the server to the client? But the moment I need bidirectional communication, I have it, right? There isn't like, I only needed one way. So like to me, I don't find it relevant. And server sent events, this may have changed, but there is a limitation on the number of connections per host that you can have. So like even across browser tabs, I think it was like 6 connections or something. And maybe with H2 that has changed, but there were caveats with server sent events. To me, it was worse feature wise. And the whole point of channels is they abstracted it. So I can imagine a server sent event transport that like posts to the server and effectively is like the way long polling works, where you could have server sent events pushing from the server to the client, and then you post messages, but then it's just long poll. So to me, it would be worse implementation and less features. So the whole point of channels was you actually don't care about the transport. So there's my take. Server sent events irrelevant.
You recently introduced the concept of durable servers, and listening to your keynote at ElixirConf in Europe in Malaga, it's something we in the airline world have been implementing, and most systems have it in some shape or form. It's a must when reliability is one of the core properties of what you're developing. But what I find interesting is, they never made it into production in OTP, in any of the libraries, or even in the semantics of the language. So yeah, it will be interesting to discuss your approach to durable servers and understand the strengths, limitations, but most important, the differences. So, but before we do, let's start with something relatable and slightly painful. What's the most memorable process you've lost in production?
This is actually interesting. So this is a recent one that at least comes to mind. So part of DurableServer, part of it is a distributed process registry and process group. And that was running happily in production. And then I lost, the registry basically cleared without other processes that depended on it knowing about it. They weren't linked, but basically a process died that I didn't expect to. And then, I lost basically callers weren't aware of it, and the callers expected to be members, and suddenly they weren't members, right? So, and this happened because I saw a PR from one of my teammates that had like defensive code that was like at runtime, if I find that a process started and it was a Phoenix channel and it joined a process group, and then I saw this PR that was like, at runtime it was like, if I'm not in the group, add myself to the group, and I was like, well, why would we, this is like, why would we do this, right? Like, we don't write this kind of defensive code in early Elixir. So it turns out like they had this case where they at runtime were no longer a member of the group, and it was like, well, that shouldn't happen. So it turned out the group supervisor had crashed, and I was like, well, this is impossible. This shouldn't have happened, right? Unless someone like send an exit signal. There's no reason it would have crashed, because it's just a GenServer that writes to ETS, and I could not actually come up with a reason why the code would have like had a match error. So it all came down to, there was not actually a bug in the group library. It was, my supervision tree was wrong. I had group was inside a sub tree that itself went down, like Rust for one. And so something crashed in that tree that took group down, and then other processes requiring that. So the fix was basically group should have been up the tree and shouldn't have even been in that subtree. It was just like got added there at the time. Everything worked until it crashed. So it was just some good insight into someone tried to add defensive code. And then my first thought was, that's obviously wrong. And then my next thought was like, well, am I missing? Does group actually say, like, does group need to link the caller to a supervisor or something? So they, don't end up in this orphan state. And then usually, sometimes that's okay. But that thought was like, well, no, like linking has costs, and like, that supervisor shouldn't have crashed. So then it's like going one up in the tree. It's like, we had the answer for this all along, which is this, the OTP structure was just wrong. So it was actually just an interesting insight into, it was just ultimately a supervision tree, and it was the fix was just like, delete this line, add it here above in the tree. So it was that just comes to mind as OTP has these patterns for us, and the fix wasn't all the defensive code down lower. It was just a very simple change, up top.
What was it, a coding agent which designed the supervision tree?
So this is definitely my code, and I don't. So I think this is. So okay, hold on. So yes, in that the coding agent likely wrote those lines, because I'm very lazy and I have it even do like one line changes. But it was my fault in that it was actually inside the DurableServer supervision tree. But so this is a long answer. So DurableServer group came out. I extracted it from DurableServer. And then since DurableServer started this group supervision tree for itself, I was also taking advantage of that outside with non-DurableServer callers. That was there. I could just call the group by name. And the insight was like that was just the wrong level of isolation. So like Phoenix channels should be joining a group instance that doesn't depend on this other thing. So it was my fault, but it wasn't. I wouldn't say it was LLM slop. It was just I started with this narrow, like, DurableServer needs a process registry and group, and then I was like, oh, I have one there, and then it was just basically a process, really dependency fault that I shouldn't have been relying on this thing that was part of. I don't know how to explain this, but it wasn't. I'm going to say it wasn't AI's fault. It was my fault, but I can't say for sure that it wasn't Codex that wrote those lines.
Fair enough. Well, I mean, reminds us that, it's you always need to review, especially things such as supervision trees and dependencies in supervision trees.
That's what it is.
You
And
really need
the
a
issue
human.
with that is like,
exactly.
but you don't know.
It's
Even
tricky.
I think my intuition was wrong. My intuition was wrong at the time. And I don't know that I would have, even with a review, I don't know that I would have caught this until I experienced it. So I think like there are some obvious things with supervision tree structure, like ordering is very easy for me to be like, oh, well, this is obviously wrong. Like, if something is initializing in the wrong order, it's not going to work. But this was like a obscure case where order was fine, but the isolation level was wrong. And those are harder to catch, harder to obviously catch. I mean, obviously if I did a deep dive thinking about these specific kind of things, but it was an ETS table disappeared that shouldn't have disappeared, right? And it wasn't an ordering issue. It was really an isolation issue.
Yeah, exactly. Always is, but that's why I always say it's always a good idea to let the system architect go in and design and design this part, the code, understand the durability, understand the supervision structures, understand the dependencies, and so going talking about durable servers, let's introduce them. It's not about adding features. It's more about removing entire categories of problems. Can you tell us a little bit about them for those who've not listened to your keynote yet? And for those of you
Sure.
who haven't yet, I really recommend you going in and finding it on the CodeSync YouTube channel. But can you tell us about durable servers, what they are and what they aren't?
Yeah, so it's a durable process. If you're familiar with beam processes like a GenServer, we have this ephemeral state. We start in this known good state, and we have all these callbacks that can change our state. But if we crash, that state goes off into the ether, and we start from scratch again. So we're all familiar with this process, and I think a lot of us, necessarily have durable state that we need to keep around, whether that's in a SQL database or elsewhere. And most of us have kind of this ad hoc code that's saying on GenServer init, I need to kind of hydrate and build my ephemeral state off of some known good state in a database somewhere. And we all have this code that goes and fetches that, adds it to some GenServer state that we need, and then we have this stateful process that's doing work. And occasionally it can persist to whatever data store we have, SQL or S3. And this is how a lot of us go about, doing real work in real systems. And this works great. I think, these patterns were familiar, instead of writing.
Great. It will work great until the database gets corrupted. And that particular entry is not updated because of a crash.
Yeah. So it works great. And a lot of us can intuit that it offloads all this, instead of relying on the database for everything, we are just periodically saying, okay, now this is what I want to be consistent. I'm going to persist. And this is how one of the ways that Erlang and Elixir systems can achieve high scale building real products, right? It's not like a lot of other programming languages have to rely on the database just to do concurrency, right? So it's one of these patterns I think we're familiar with, but what I needed out of this product we're building called Sprites that Fly is at scale. I had a geo-distributed application, and we had issues of there were several issues in one. It's how do we locate processes? And we can all think okay, process registry solved. And it's well, how do we get process into how do we hydrate that process? And one of the hard requirements that I was building in Sprites was avoiding a single point of failure and avoiding having to go across the planet for data. So we had this highly available requirement. Yeah, so it was we started kind of splitting the app regionally, and we kind of naturally arrived at this, I think, idea of Cloudflare has durable objects. I think lots of developers can kind of internalize what that means, but it wasn't. I didn't start with let me just add durability to OTP processes. It was kind of we had this ad hoc GenServer code that we were pulling state out of some durable store and hydrating. So I kind of naturally had problems that. We had all this messy code that I was solving one by one, and it kind of became something that was kind of durable objects for Elixir or Beam. It was a kind of this natural progression of, I didn't start with, let me make this library. It was let's ship this product. And then it was wow, this is really messy. And some of these processes we were starting are pretty IO heavy. They're running their own SQLite databases on the API server with Lightstream, which is pulling the SQLite WAL file, and that has its own CPU bound work. So it was now I need to start distributing the load for these things. And so it's not just the matter of I can hydrate a process and start it, and Beam is good for millions of those, but it was now some of these processes represent real work in the system. So we started writing load balancing code of these processes. So it was kind of all these little problems together became something that we're oh, oops, we accidentally have this ad hoc durable object thing in Elixir, or kind of Orleans virtual actor framework, but it didn't start as let's go build that. It was building this real thing, finding out that it was really kludgy, a lot of ad hoc code. And then we kind of, I took a moment to be all right, we need to actually kind of peel back some abstractions here and make just this code that we have to maintain not suck. And then I realized that it was oh, wow, this is a general purpose library. But it was a very organic process of not starting from let's build durable objects in Elixir. It's we're building a real product, and then oh, here are the abstractions that we actually needed, and they're actually working.
I'm kind of curious about what kinds of systems would actually require durable servers, because I haven't heard people kind of saying, oh, we really need something like this. At least I haven't heard it. So I'd like to hear more about
so I think of things. A lot of people have needed this, and not needed. You can get around this. So One of the things is like the subtitle of my talk is always running somewhere. So like the very, very basic things. So if we start with, I have a global singleton on my cluster that does some work periodically or something we would put in a cron task. Like there are various things that there are like cron libraries for Elixir and Erlang that either use literal cron or the beam will schedule something. You could use Erlang global to like try to enforce only one global singleton. But we have this problem of like sometimes we just want to have one and only one process running somewhere. And our level of guarantees there can be different. Like maybe during a net split, having two is fine, but sometimes we have to think carefully about like if I have two of these running, I could have a double transaction somewhere. So we all kind of have had this before. It's solved in various ways, but for me, this is like one of the obvious things that people hit. And now like the thought is like you don't even have to think about it anymore. You're just like, I'm gonna ensure that this child is started with this global key and it'll be running somewhere, right? So this is like the very simple case of you don't need load balancing. You just need a global singleton, and you don't want to worry about like how do I have the consistency and guarantee where that thing was. And then you want to pick up where you left off is another thing where all this kind of ad hoc code that we're used to writing on like GenServer init, go fetch from SQL, go fetch from wherever. It's often state that like a user session is often state that like has a different level of guarantees. Like if we lost this state, we don't want to lose it, but it wouldn't be the end of the world, right? We don't need an ACID transaction, but we do need to pull the state from somewhere. It's often in SQL because that's a data store we have. So there's just ends up being a lot of this glue code to just get that process started with some ephemeral state that we care about that's fast to access. Then we also have this case of many of us running Beam at scale. You have like one thing I love about Beam is you have a playbook that you go through to solve almost any scale problem. Like, and there's very few ways that you solve these problems. And one of the things is like if you have a process and that process is a bottleneck, what do? It's like, well, you either add more of them, right? You add a pool, or you call the process less, or both. So one of these common patterns are like that process will own like an ETS table, which is like fast in memory, cheap instant access. And you hit ETS instead of hitting the process, and you only hit the process when you need to. So we all kind of go down this path. And part of what came out of DurableServer was there's the durability aspect, pick up where you left off. It just hydrates itself. We can load balance for you. And then we also have this idea of metadata. So since it's a built-in registry and process group, that process can at any point export metadata that just gets replicated globally. So now you have this like offloaded ETS optimization that this path we all go down case by case basis. Now it's just there, right? So these like little things that you're solving in an ad hoc way over and over and over just become part of the system. And then it also kind of has a built-in like pub sub notification layer as well that again we kind of roll in an ad hoc way. So since it's a process group, say you want to know, okay, this process started on the cluster somewhere, like, and you want to know this process went down on the cluster somewhere. Now that's all built into the interface on like reactive code somewhere else in the cluster wants to know when this user session comes up or this global singleton comes up. Like that's all just built in. So I think it's like a very, very common abstractions in one that are kind of necessarily coupled together when we start talking about like durable state and these things living transparently around the cluster. So I think that this is more broadly applicable than kind of like the sprites. Oh, I'm running this across the world, so I need this. It's more very common problems that you can just like, shed from your head without it being this big framework, right? It's really just a GenServer abstraction. You reach for it in the same way you would reach for a GenServer. And instead of owning your app, it's just this GenServer that happens to like solve all of these little things you would otherwise have to solve.
For a seasoned Erlang or Elixir developer, GenServers, it's not really something that we need to really think about. It's kind of like second nature to pull one out when you know that you need it. But DurableServer is something a little bit different. There's some similarities, but I'd like to kind of understand like what kind of mental model in my head should I have when I start to plan out should or should I not use a DurableServer, and when I do use it, how should I configure it?
Yeah, I mean, I think the biggest thing is like, does this need to be globally addressable? Does it need to pick up where it left off easily? And if those two if answers to either of one of those is no, like then you definitely just start a process, just start a GenServer. So I think it's pretty easy answer. And the nice story as well is the moment you're like, oh, I actually do want this. I have this GenServer, right? And now I actually do want to actually have it always running just somewhere. And then that's a very easy thing to say. Instead of use GenServer, it's use DurableServer. right? You add the load state, dump state callback, and then you're almost done, right? Everything is just got to work other than changing a couple call sites, right? Instead of dynamic supervisor start child, it's going to be DurableServer supervisor start child, and then you can call that from any node at application startup. They can race each
Yeah.
other, and you have this global singleton, or you can.
I'll step in here because you were talking a lot about retrieving the state, from a database. When people say, just restart the process, where do you see it falling apart in real systems? And
Yeah,
I'm
so
thinking of durable
the,
servers in mind here as well. It's where have you seen, issues arise?
Yeah, so this has come up in the past, like this idea of like, well, what if we just put all GenServer state in a database, and then we wouldn't have like, this idea has been floated in the communities like for years. Someone will ask about it, and the conventional wisdom is like, well, the whole point of a supervision tree and a process is like, you have your start link args, which is your init args, which is like a known good state that you then start from. So you don't end up in this case where you're in a bad state and then you go to start in that bad state and you permanently crash forever. So this idea was like it's good to have this split. And I will say that this is still a concern. So DurableServer callbacks, they force you to all of the data does carry a version, and if you change the shape of that state that you're storing, you do necessarily have to migrate that state. And the callbacks to get to the init callback require you to at least accept the old version, and it's on the developer then to migrate that data, just with like a case, pattern match. And if they don't do that, or they get into a state they didn't expect, you could end up in a permanent crash scenario. And in these cases, DurableServer actually has it's configurable. We have a crash. We keep a crash history. Like you can crash at runtime, right, for any reason. This can happen for unrelated to the storage, but in any case, we keep a crash history, and we also avoid the I'm just going to attempt to restart this forever until the end of time. So there's a maximum, just like similar to supervisor has like max restarts within a threshold. We have the same idea where we will actually permanently we will mark it as permanently crashed, and it will never be eligible for a restart until your code explicitly either tries to restart it again, but then that could also be then in a permanently crashed scenario. So it's never going to end up in the case where we just are like restart forever. And if it does crash, it can be repaired and started again explicitly, and that may require bug fix. Like, oops, I need to go actually write the state migration to get this shape that changed that I didn't address. So it definitely can happen. The primitives are there to at least prevent it from, system overload, constantly trying to restart this thing across the world. It's especially if you're using the object store backend, you don't want one permanently crashed attempted restart thing to it's like, oops, I crashed one process and now my bill's $10,000, right? So
how much
for that reason alone, we need to add the circuit breaker for this, but it is something that we protect against, but it would require like you go fix the bug, right? So that process would basically fail to start over and over, hit the circuit breaker. You may have code that tries to start it again, may hit the circuit breaker of failures, and then you go fix the bug, right?
But we always talk about systems which self-heal, and in what we've seen, I mean, what you say makes perfect sense. Until we start thinking about gaming, where the state is in constant flux and changing, or IoT, where telemetry data is coming in at often at very fast rates. And what I found is that when you're going in and after a crash, when you're restarting, you need to move a lot of that business logic move a lot of the recovery and the recreation of the state into the business logic of the process itself. So you
Yep.
cannot, what I assume
Which
needs
I
to be
think is
done with
fine,
durable
right?
states as well. Yeah, exactly. It's what we talk about, system self-healing. They need to go in and say, there's been a crash. Could it have been my state which caused the crash? And if my state is corrupt, and this is which most likely is, it's either a bug in the code or it's a state which corrupt which causes the crash. Let's go in and try to recreate the state from the ultimate source of truth, and that source of truth, where possible, shouldn't be the database. It should be the events possibly which caused that state change in the database itself. And that's how we solve this in the Erlang world. And often, if we weren't able to solve it on a process level, that would have caused, 2-3 crashes, and then, the exit signal would escalate to the supervisor, hoping that maybe, the corrupt data is in another part of the supervision tree. By restarting that part of the supervision tree, we would then fix the problem. And so eventually, when, the server which triggered the first crash was restarted, by recreating its state, by getting the data from this other process which had just been restarted and fixed its issue, the startup would be successful and the system would have self-healed. It creates a very, very different mental model which needs to be adopted when working, when working with durability and when working with, the whole restart mechanisms. When we're looking at what you're basically doing is you're extending, the GenServer contract with durability. What is it which breaks, the traditional model, that GenServer brings? You're basically pushing the notion of durability, but what needs to be done differently now, to ensure that a restart works? And is there any other gotchas which we need to think about?
Yeah, I think it's actually been far less of an issue than I thought, especially with like teammates kind of taking in this idea as far as like something being permanently crashed. I actually have, so we've been and this has been in production 7 months now, and I could go check our dashboard. I think we have not ended up in a case where we've had to go resurrect bad state and transform it like outside the context of code, if that makes any sense. Kind of what you said, like you can write the repair code in the GenServer itself, but we've never ended up in a situation where it's like we need to go in and like poke the data itself because we can't get out of this. But I will say part of the way to avoid kind of foot guns is like it's not that we take the Erlang process and now all of its state becomes saved in a database, right? So I think an important key here is like you were really only storing the durable state that you absolutely need to get back to your ephemeral process state.
And that you're absolutely sure is not corrupt. Yeah.
Yeah, and that state that you basically the only thing that needs to be durable is what you're writing to the store, and that should be the minimal state necessary to accomplish your business needs. And that also kind of protects you from, we had this giant shape of a bag of data, that we conveniently is just saved for us. So I think that part of it is kind of using that contract of like, it's just a GenServer, and then if only we had these small bits to get back to that point, and then these small bits we persist back that are necessary to be not lost, whether that's like where the user session, like this whatever makes sense for the business problem that we need to keep around, it that has protected I think a lot of this problem of like now this map that we had in GenServer state that somehow automatically gets persisted. It's not this automatic persistence of process state. It's more durable state that just happens to be co-located with the process that you use to build GenServer state back, and that you then can persist over the life cycle of the process. So does that make sense?
Correct. Absolutely. Yes. I don't think we're being loud about it enough. Right answer, Chris. Yeah, thanks for that.
And then while I was answering that, I just want to say, like, I pinged a neuron with the Alan's question earlier about when I would think about reaching for DurableServer. One thing that's really nice is being able to place a process in a specific spot. Like you may have like a region, but even thinking something, let's say like I'm just running in one data center, I may want to do some file work, right? And it may be really nice if I could just have that process always then start where it left off on that node. And then maybe if that node disappears forever, I then fall back to some other node. But we have this problem at Fly of like, we're using a lot of multi-tenant SQLite databases. And those things are stored on object storage, but we obviously don't want to clone the entire database every time we spawn a process, right? It's like we've done that work before. It lives on this server. Every time this process starts, ideally we just place where that thing exists on disk, right? And then we fall back to the failover case of pulling this asset off for some cold start. So it's like these kind of like placement problems is just another class of like answers in my head of like, okay, I definitely would just reach for DurableServer then. I just occurred to me that's definitely a check mark on the decision process.
What I wanted to ask was that we often treat processes in Erlang Elixir as very cheap and disposable. What's kind of like the cost of cheating it like that? Because like with durable servers, you want them to stick around, right? I mean, you want them to be durable. That's the name. What's your take on that?
Extremely cheap. So you should be able to run just as many of these as you can processes. I mean, that durable state has to live somewhere. That could be object storage. There's costs with, every put or get request you have, but that could also be any storage backend of your choice. So it could just be your Postgres database or this EKV library that writes to local disk that we have a backend for. So I think that the cost is really these things are super cheap. So I wouldn't consider it much different than what I'm thinking about process wise. But if you're using object storage, obviously if I create or place 1 million durable servers on object storage, that is 1 million put requests, right? So I don't know what the price is for whatever AWS region you have for that, but it's something to consider. But then you could also use your Postgres database, and then it's effectively free as far as however much data that takes, but pretty marginal.
Now, I'm kind of curious because starting processes in Elixir and Erlang is so cheap. I mean, at 1 kilobyte a piece. Like, at what point do you think that having so many processes running becomes like a liability to your system?
At what point? At the point so this is like a non-answer. At whatever point that becomes a problem, we have the standard playbook of like you add another node, right? So I don't think this isn't a problem I think about often. It's like usually we're mostly operating on the scale of like, if I wanted to represent my example in the conference is a good one. Like I wanted to show like if I build a ride sharing application like Uber, I asked ChatGPT what's ballpark for me the maximum or the average concurrent rideshare rides at any given time on the planet, and whatever AI search web whatever it ballparked 500,000 active rides at any time. So like as a business we get some requirement and we're like, well, how many what's the scale? We hear a thing like, okay, I want to support 500,000 or 1 million concurrent rides. And then we go to Beam and we're like, that's pretty easily represented on, really moderate number of hardware. The WhatsApp is the classic example, right? How many active chat rooms and users could we have? And the answer is basically like, how many do you need? How many million? And we're fine. So I think we have a standard answer here, and DurableServer matches the same. It's the same answer, right? It's like we're not limited by the Beam process likely, and we're not. If you're using object storage, you're basically this elastic scale of this several kilobytes of durable state isn't going to be your bottleneck. So I don't think that there's the effective limits, especially at the scale of Beam, become other things. It's usually something downstream, something upstream of you, the payment gateway. So I don't have a good answer here for where does it become a problem, but it's the same answer usually I would give if someone came to me to design something on the Beam. It's just like tell me your requirements, and then it usually fits within a very very moderately sized cluster. You know what I mean? And at whatever point this does fall over, it's usually we find it out in prod, and usually we have answers for how do we continue. So does that make sense? Francesco may have
does.
some insight here.
I do have insights though, because if there was a ride sharing app or an Uber like app, and quite a few have been implemented in Elixir. So yeah, and Erlang as well for that matter. I would not go in and have a process or a durable server for every ride which is ongoing at any one point in time. I would more go with an event-driven design where for every state change you go in, you create a new process which changes and handles that state. And then when you're done with it, you then go in and store the new state in a persistent database. So it's a notion of durable servers, but bringing it a step further where the process doesn't remain alive. You just create a new process for that particular ride. I mean, this then allows you to scale. And this is a design pattern we started using when processes were limited, when we maybe had a maximum of 30, 40,000 processes allowed at any one point in time in the VM. We threw memory at the problem. We stored the state in memory, but this allowed us to handle 30,000 simultaneous events happening at any one point in time. And that could be Someone starting the ride share, someone finishing it, someone paying, someone providing feedback, adding a tip, changing destination, or adding an extra stop. And so what this moves you from is allowing 1 million concurrent rides to 1 million users simultaneously on the platform, changing, paying, and doing something different. And it's so yeah, going from 1 million events to 1 million concurrent rides. That's a huge magnitude of scale, which you're then still able to handle on the same node, and you still have the process of durability. So maybe yeah, that could be some food for thought, Chris, and maybe yeah, next year you will you'll
Yeah, I
present a
mean, yeah,
durable
I'd have
state
to.
server.
Yeah,
Yeah.
I haven't. Yeah, in my contracting years, Uber unfortunately didn't come to us. So,
I,
outside of a prototype, I
I,
could say I haven't tried to spec this out. But I will say, like, it does, having a process represent a ride does give you quite a bit. I mean, I think, like, as far as like presence goes, is that driver online? How many of them are online? It's there's certain things that a process absolutely helps with here versus, like, if I purely had some level of like durable event log, I would have to then kind of realize a view of that and then query the view, and I wouldn't necessarily. Yeah, so it's trade-offs. But again, this is something I'd have to try to build for real. I'm sure. I imagine it'd be a mix of both of these kind of things versus, like, I do think we have to be careful, to your point of when people go designing the beam, they often are thinking of, well, I'll just model everything as a process, right? Every single entity in the system, and that's
and,
definitely can be a wrong mindset for sure.
and I mean the big difference is yeah, processes are cheap, but creating processes are just as cheap. And so by creating
Yep.
processes with an event-driven architecture makes it so much more scalable. And obviously you wouldn't have, you have to be careful not to lose all the features you just described, but it's just a different mindset and a different approach. And we started with this mindset and approach when we were dealing with telephony. There's no point in having a process up for during the phone call. It's only when you started the phone call and only when you hung up the phone call did you need and we're dialing did you need the process. But
Oh, so yeah,
when
okay.
two end
I
users
think
were
I
speaking,
think
yeah,
we're aligned here then. Sorry, I
yeah,
thought you were trying to remove.
yeah.
So you would have, like, during an active ride, you would have a process. Are you saying you would or would not have a process representing
I would
the
not
ride?
have it during an active ride, but whenever something happens in that active ride, I'd go in and create a process. I mean, it makes debugging and troubleshooting so much easier.
I see.
Try tracing. I mean, assume you've got 10 million rides, but there are only 50,000 events happening at any one point in time. It makes your tracing, troubleshooting,
I
finding
see.
where issues are occurring so much easier.
Yeah, I mean, I will say our durable server dashboard in production, we can just trace a durable process at any point,
Mm-hmm.
which is actually interesting, because to do that, you need to say, like, well, is this thing running to even start the trace? So what we do is,
Yeah,
like, a durable server has the idea of, like, monitoring a key space. So I can just say, when I start
yeah,
this trace, I'm on, like, where we have 20 nodes right now. So it's like, well, how do I trace a process that may be on one of these 20 nodes or may not be started yet, but I want to start a trace, and then I'm going to do
yeah.
some work with side effect that will have started this process. And how do I start tracing that? So we have that tooling built
You did.
in. We have a dashboard, and then I'm tracing. You're right. It's not a durable log of the events,
You,
but that dashboard will show me all the messages to
yeah.
that GenServer, right? And then I can kind of see what goes on, and then I can
And
also see the durable state that I have. So it's like, I do think that we could probably get something pretty close to this, but I do think, in general, like, some kind of, like, this event sourcing idea is kind of a gold standard for, like, if you need, like, the forensic analysis. It has some really
but
really nice properties.
you can do that. You can go in and actually trace processes. Triggering the trace when you're pattern matching on values. So what you would do is you would probably be tracing on that particular ride ID or a session ID, and you go in and you trigger the trace events only if the first argument of the function call, when
Yep.
you're spawning a new process, is a particular session or a particular has a particular ride ID which you want to go in and monitor. And it's a bit more complicated to set up, but once you've set it up, yeah, it's infinitely scalable. the good thing we
Yeah,
found
but
is that
I was gonna say I could screen share here. So as far as like being there, done that. Again, I think
yeah,
tracing is worth talking about. So let me see if I can pull this up. But let's do a live demo. Let's see if this works.
go for it.
So we'll see if I'll let Alan click that. So let me see if I can cause. This is what I kind of showed off in the conference. This is a web dashboard built on DurableServer. It's not everything we see here is like just in our production app. So this is a live view, but it's calling like public DurableServer interfaces to render this. So basically, you tell an LLM, here's DurableServer docs, build me a dashboard. It will give you this, and I know that because this is an LLM built this dashboard. So so we have process information here. We can actually see I do have a crash history 22 days ago. Looks like we had a timeout from elsewhere in the system, so we keep a history of that. I have my storage state, but this is where I could start a trace. And this thing is currently running, but if it wasn't running, I could still start the trace. So it's going to find that on the cluster and see if I can send a message to this thing. Oh, all right, it's getting messages. Let's see what happened here. Oh, it's emitting like usage data. Actually, this is interesting because I thought I would have to do more work to get this thing to do things. But yeah, so there isn't an event log as far as like I can go see what this process did, but I can at any time go, and find wherever this is running, or if it's not running, what happened. So let me actually see if I restart this, if this just keeps working. So I just killed my process here. Let's see if it gets restarted. I don't remember if these things are permanent durable servers or not. I know it will get restarted. So I guess this is a good demo. So if I do a sprite list here, that's going to hit the API. That's going to do, oh, there we go. I have that service, that request, and it should be alive here now. And it was, so this is, there we go. Started on demand in this case. Like, so your code is basically like, ensure, so we have like this idea of like start child interfaces in Elixir or start link, right? So this is basically a ensure started call where it's like find or replace this. And if it's going to return you okay PID, right? So this thing is now rerunning back where it left off. And the other cool thing I can at least show while we're here is I have this running in Paris right now, but it was placed in my home region would have been in effectively US East 1, like what we call our IAD region, because that's where I live on US East Coast. So I moved it as a demo during the conference, but at this point I can rehome this process, which is now pinned to the Europe meta region. So now this process will always be eligible to be started, and it's going to try to start it on the machine that it has its database on. But if that fails for a gated time window, it will be anywhere in Europe. So I'm going to move it to back to US East 1, or attempt to. So we'll see if this works. Okay, so now this thing is in IAD. We see it has a new PID, and any caller around the world can now, continue calling that thing even while it was being moved, and we can see I get my data there. So what happened behind the scenes is that we actually this was a cold start, so we actually pulled the SQLite database off object storage for my organization and put it on IAD next to this process, but the same machine that this process was running on. Your callers, right, don't really have to care about this, but you have to think about the speed of light and where these things should live. But in general, we can move these things around, and we can keep them close to the user, or manually have code that actually moves them. If a request comes in and now that user flew across the country, you can imagine business logic that actually automatically relocated that for me. So
you're doing event. So
you've
got everything you need. You have everything you need, for an event-driven approach, because as long as the user doesn't even need to know. In their mind, yes, it's a process which is alive all the time. But in fact, what you could do behind the scenes is hibernate it, terminate that durable process.
Yep.
And as soon as an event, which is directed to it comes in, you spawn it up again, you recreate that state, you recreate the state.
Yeah,
and
exactly.
Then
So it's on the developer to by default, they're not permanently running, but it's like, it depends on your business case where you could have it always run somewhere, or, this process decides to stop itself gracefully. It will never be restarted until a code path says start for me. So yeah, absolutely.
Exactly.
You're only running the things that you want to be running.
Exactly. And I think the main lessons we've learned is remove this from the hands of the developers and take care of it from behind the scenes. And at that point,
the least you have to care about this, the better.
Chris, I wanted to kind of go back on something that you said before when we were talking about the durable servers. particularly about like what use cases there could be for. In what cases do you think that a engineer would actually end up kind of creating their own version of a durable server?
I think that this happens all the time. Kind of like I mentioned, like you may not need all
Yeah.
aspects of this, but I think we kind of all hit these cases of like the obvious one is like I have some state from the system in storage that I care about that I hydrate this process state from. It receives events. It does a bunch of ephemeral state stuff that we know and love. We usually like to tout to non Beam developers, like you don't just have to like throw everything in the database just to pull it out, and you basically don't have to create these stateful systems by means of throwing everything in the database. So I think we're all kind of doing these small bits and not thinking about kind of the complexity it adds over time. So for me, it's not that you should write everything with this, but I think the cases that you start hitting where like I have the state I'm only putting in my SQL database because it's convenient to then hydrate the process with can now be like, okay, there's this alternative here where I can kind of co-locate these other things together. And maybe I don't need to talk to SQL at all, or maybe that becomes just like less of I'm not just relying on a central data store because that's a convenient place to put data. But that also is fine. But then we start getting into like load balancing where let's say my use case is to start tens of thousands, hundreds of thousands of processes. Like you can't just say, well, wherever they happen to load balance to, just start a process there at scale, right? You usually implement there has to be some level of load balancing. The hill I kind of die on with my non-Elixir peers and friends is like, usually folks think, well, the HTTP load balances requests, right? So what's the problem? And it's like, I like to tell people that that's the entirely wrong level of granularity on like, your HTTP is load balancing HTTP, right? And what happens in your greater system there needs to be load balanced. And that could be a whole host of potential IO or CPU bound work, but it's not just like servicing a web request, right? People are stuck in this idea of like web request database call, we're done, right? But in a stateful system, that web request can come in and that may need to do something in some other location somewhere else, and we need to load balance that. So I think those are the things that come to mind that were most obvious that we had to build is like, okay, we have this process we can easily spawn. We maybe can co-locate the data next to it, but now we were running into like CPU bound work with SQLite or IO bound, IO bound work. We can only do so many SQLite writes until we're starving IO. And now how do we start load balancing those things? So it becomes like all this like kludgy code that now you can just have it work, right? It's not like kind of the point of like, it's a solved problem in that you're no longer thinking about it and you add a new node to the cluster and the lifecycle manager from DurableServer just starts balancing these things for you.
Does this move us closer to the original airline vision of write once, run forever? Or are you seeing this as something new?
No, I think so. I think it's like, Erlang, I initially came to it exactly kind of from this idea of like, you write it on your laptop, and what works on my laptop is now spanning the globe across 20 servers. Like, the Sprites API is running in North America, Europe, Southeast Asia, Sydney as well. So it's like we're running a geo-distributed Erlang cluster, fully meshed, and it works
That's
against
why I say
conventional wisdom.
run
Conventional
forever.
wisdom is you
No
can't,
single point.
conventional.
Yeah, no, but yeah,
Yeah.
that's what I'm saying. No single point of failure. You can basically run anywhere, and if you lose a data center, it will still be up and running. That's what I mean by run forever.
Oh yeah, I mean, yeah, that's the dream, right? And I think that my mind has been on like, I am intrigued by this geo-distributed mesh idea, and I actually love that. Like, I had a real business case to make this happen with Sprites. So I will say, not everyone needs to be running cross-planet, right? But lots of us would love to be running in maybe US East 1, but we want data center out capability, and usually that takes, I mean, a massive team of engineers to solve, right? And we could have a case where you could be running very close to each other, but you want, region out capability, and you could run, your cluster across very close regions and have, very few trade-offs speed of light wise. And like you said, Francesco, always run forever, short of, a natural disaster. So I think that does gets us closer in that Beam has always really allowed this, but it's now like, instead of a whole team of people, it kind of pushes that problem down the road of now it load balances across data centers. Your routing across data centers is just a process SYN, like we always talk about. So it pushes that out for what a single, developer can accomplish. And I think they can kind of accidentally end up in a case where, their customer says, okay, well now I want, region out redundancy. And now the answer won't be, let me get back with you in a year, right? Let me hire some people. Now the answer could just be, you go provision that thing on whatever. Yeah, you and it's a less than a day of work. So I think we are closer. I think Beam has always allowed this, but my goal with this is kind of like the abstraction. I want it to be small enough that it doesn't own everything. It's just like reaching for a GenServer. But now, if you reach for this, when you have these needs, it solves this whole class of problems for you, and maybe a whole class that you didn't even know you needed to think about is maybe already solved. And I think Beam is kind of represents what Beam gives you, right? Like this whole thing that you may not even be thinking in your head is already solved. And then time and time again I've been in this ecosystem 12 years, you say like, oh, but I need to do this now. And it turns out 20, 30 years ago that other humans had this problem and they put it in they solved it in Beam. So it's like over and over again, I do think this is just moving us along that track of it's just there. And it's not like we over-engineer these things. It's like a real problem existed. And Beam happened to solve it in the perfect way imaginable, right? Before everyone else is even thinking about it. So I do think I'm trying to. I think it kind of aligns with that mindset, right?
It's a whole mindset which we've tried to push through, where you design your system to run on your machine, you develop it on your machine, and then without you being aware of it or having to do anything, it will then distribute itself across a cluster of machines for two reasons: scalability and reliability. Reliability meaning that if you lose any one instance, the end user shouldn't be noticing it. And at the same time, scalability. If you get a spike of users, they'll all be serviced and they don't notice that there is a spike going on. So this sounds exactly like that. The envisions it sounds exactly like that.
For the durable servers, right? If this idea and method catches on, how do you envision applications being written, right? Is it just like no need to ever have a traditional GenServer anymore, or what are you kind of thinking?
No, they're absolutely. I mean, you absolutely still use GenServers. I mean, we still have a ton of GenServers in the Sprites product. So I think like anything node local, it's just gonna be obviously GenServer. There's like, I take that back. I mean, that's the wrong. You could have a node local GenServer that you also want to kind of pick up where it left off. But I think in general, like your intuition should be like reach for GenServer when you reach for GenServer. You still do that today. And then the question is kind of going to be, do I have these specific requirements? And as you do, the transition for now, I want a durable process, or I want it to be pinned to a specific location or region. Like now, it's just going to be a couple line change, and you can get those qualities now. So it's a very natural progression. So I don't think it's a big upfront decision. The goal is like you think about it the same way you think about structuring your OTP system, but if you need that process to be globally addressable, you want it to be able to pick up where it left off. You care about how it gets, or you don't want to care about how it gets load balanced. Maybe you only want it to run close to the user. You always want it running. All these things, if you want these qualities, you just opt in, and that opt in could happen up front or it could happen later. And that's kind of the whole goal with this. I think some people, the feedback I got from my talk is I kind of undersold it. But the goal was for it not to be, this grand new way to build an OTP system. It's just a GenServer, right? It just has these qualities that are solved for you as you need them.
For your presentation, right? So we've already told your viewers/listeners at home to take a look at the presentation. Is there any one particular part of your presentation that you think that they should really focus on and take home and just consider it?
Yeah, I mean, it's hard to pick on one spot. I mean, I think if you kind of already intuit this idea of like what object-oriented developers would call like durable objects, like Cloudflare has this SaaS, you could skip the beginning. I mean, I think the demo at the end has some. It's just an interesting example, but I think it's hard to just key in on one thing. I mean, one thing I show at the end, if you just like live demos, the high risk, high reward. I do show 500,000 durable servers representing a ride, and I kind of like simulate a UI for like what Uber app would be. But I roll, like I restart one server in I think the UK. I just pick one server on the cluster and restart it, and it's running like 12,000 durable servers. And we see in real time the UI. We see those servers go down instantly, and then we see them getting restarted by DurableServer itself, right? So I think as far as like self-healing systems and processes being restarted, it's just an interesting example of like kind of the qualities we've always used Beam for. Like, things can crash, that's fine. We can kind of see this start failing over on the cluster automatically. And the cool thing with DurableServer is that those processes are failing over to just that meta region. So it's like kind of this quality of like, when would I reach for this? It's like, well, when you want the same qualities of OTP, like restart that process if it should have been running, but also, the LHR node went down, but any LHR FRA is another region in Germany. So those processes, 12,000 processes just start, you see it ticking up and getting restarted back close to where they should be running. That's the fun, most enjoyable part, but I think holistically, you should watch the whole thing.
One last question, and what's this one assumption, about Beam you think developers should reconsider in 2026?
Definitely multi-region clustering. I think that we've had this tribal knowledge that I also internalize, which is like Beam was designed for, you own the whole data center, so it's going to be just single data center, low latency. And I just assumed that this was true until, I think just very few people tried this. And fortunately, at Fly IO, we're multi-region. So I just started saying like, well, let's just deploy multi-region and see what happens. And it turns out it's mostly fine. So I think that the intuition that Beam can't do very large number of nodes, I think there's certainly a bottleneck there. But it's multi-region. It should just work multi-latency. You'll want to up the ZBBL. I think it's like you want to up the busy socket limit. That's the only thing I've hit where if you do have a spotty connection, Erlang defaults to 1 megabyte before SYN becomes blocking, which can be quite surprising because we consider process SYNs to be free. So it turns out like the Beam will preempt your process if it's trying to write to a PID that has buffered 1 megabyte, which is very low, right? So you want to tune some Beam args, but we're running production at scale across the planet. Along with that, I have there is a limit here. I haven't tried to find the limit, but I will often hear that Beam will break down over 100 nodes because of the heartbeat chatter getting too expensive. And I can't speak to, I'm not running a cluster that large yet. Maybe I'll be so lucky, but I will say that in my intuition there is it has to be wrong, only because you imagine the scale that these Beam clusters operate at, like a WebSocket message, right? I have WhatsApp. How many many millions of messages are going across that cluster constantly? Far more than this periodic heartbeat that Beam is doing, right? That's a rounding error. So if network wise that's a rounding error, and your intuition should be like network wise the heartbeats. Yes, it's chatter. Yes, certainly there's a theoretical max, but I think that the Beam cluster, the max cluster count can be far more than folks think. I think where this idea comes from is if you're leaning on some things like Erlang Global Registry, like there are some things on Beam that are great that do break down that if it requires like all node coordination, it's certainly going to break down. And I think this is where some of this tribal intuition comes from on Beam not scaling. Again, I'm talking about scale here in numbers that even if the tribal knowledge was true, are far more than most people will ever need, right? So I do think though that we just need to reframe multi-region and reframe really. I think we are way less limits than folks are thinking, as long as we're like, you have to start having eventual consistency. You can't rely on global locks. Like there are caveats here, but I just think we should at least reframe this.
And again, you never know when you're going to need it. So, 99.999% of the cases you don't need it, but that, you still get it for free and you're still handling, that little subset. So thank you so much, Chris, for being on the show. I really enjoyed it. And I just wanted to leave our listeners with some food for thought, right? So if processes can survive crashes, move across nodes and remain addressable, are we still designing distributed systems, or are we just designing systems again? And we call this the Beam Dead Done That podcast, for a reason. So yeah, thank you so much. And for the record, this episode was recorded April 25th, 2026.